Hello students, in the first part of chapter 13 I have explained 13a and today I am starting 13b. Here question number 1 is, if V is the volume of a cuboid of dimensions A, B, C and S is its surface area, then prove that 1 by V equal to 2 by S within bracket 1 by A plus 1 by B plus 1 by C. Here we can consider, suppose this is the cuboid, here length is A, breadth is B and height is C. Now since it is given in the question that length is A, breadth is B, height is C, therefore volume of this cuboid, it will be length into breadth into height, so it will be A into B into C. So we can write V equal to ABC, let it be equation number 1. Again we know total surface area of a cuboid is twice LB plus BH plus HL. Just because here length, breadth, height are A, B, C, so total surface area S will be twice AB plus BC plus CA, let it be equation number 2. Now in the question it is given that we are to show this part equals to 1 by V. So we are starting from the right hand side. Here 2 by S, 1 by A plus 1 by B plus 1 by C. So it will be 2 by S, LCM is ABC, ABC divided by A, it will be BC, so BC into 1, BC plus ABC divided by B, it will be AC, AC into 1 AC plus ABC divided by C is AB, AB into 1 AB. In the numerator it will be twice AB plus BC plus AC, and in the denominator it will be S into ABC. Already we got V equals to ABC, so instead of ABC we can write V. Again twice AB plus BC plus AC, we got this is equals to S. So instead of the numerator we are writing S. This S and this S can be cancelled, so we are left with 1 by V, which is the left hand side, hence proved. Question number 2 is, the areas of 3 adjacent faces of a cuboid are X, Y and Z. If the volume is V, prove that V square equals to X, Y, Z. Suppose this is the cuboid, here length is L, breadth is B, height is H, this is height, this is L, so area of this face will be L into H, area of this face B into H, B into H, and area of the upper face, this is L, this is B, so it will be L into B. Now as given in the question, areas of 3 adjacent faces of a cuboid are X, Y, Z. So we can consider, suppose L into B, this is equal to X. Suppose this part is X. B into H, suppose this part is Y. And L into H, this part is suppose Z. Clear? Here length is L, breadth is B, height is H. So area of upper face, it is L into B. Suppose this L into B is X. This face it is B into H, suppose this is Y, and this face it is L into H, which is Z. So we got L into B X, B into H Y, H into L Z. Let it be equation number 1, equation number 2 and equation number 3. Now we have to prove V square equal to X, Y, Z. Now X, Y, Z, X we know it is L into B, Y is B into H and Z is H into L. So X, Y, Z equals to L into L, L square, B into B, B square, H into H, H square. Now X, Y, Z equals to LBH whole square. LBH, we know LBH is volume V. Therefore instead of LBH we can write V. So it will be V square. So X, Y, Z equal to V square, and this is what we are to prove. In question number 3 it is given that find the volume of the cuboid whose dimensions are length is 26 meter, breadth is 14 meter and height is 6.5 meter. Here length L is 26 meter, breadth is 14 meter and height is 6.5 meter, and we know volume of a cuboid, it is length into breadth into height. Length is 26, breadth 14 and height is 6.5, which can be written as 26 into 14 into 6.5 can be written as 65 by 10. Now if you cancel by 2 it will be 5. If I cancel by 2, it will be 7. Again, 5 and 65 can be cancelled, it will be 13. Now 26 into 7, it will give 182 into 13. If I multiply 182 into 13, it will give 2366 meter cube. In part 2, it is given that length is 24 meter, breadth is 25 meter and height is 6 meter. So here L is 24, breadth is 25 and height is 6 meter. Volume of the cuboid, we know the formula, it is L into B into H. Length is here 24, breadth is 25 and height is 6. 24 into 25 into 6 will give 150, and if I multiply it will be 3600 meter cube. Therefore volume of the cuboid is 3600 meter cube, and that's the answer. Question number 4, it is given, if the areas of 3 adjacent faces of a cuboid are 8 cm square, 18 cm square and 25 cm square, find the volume of the cuboid. This is one cuboid. Here we can consider length to be L, breadth B and height H. Now it is given areas of 3 adjacent faces. Suppose this is one adjacent face, this is third one, this is second one. So 3 faces are there, and areas of these 3 faces, this one is 8, this one is 18 and this one is 25. So area of this face will be L into B, because it is length, this is breadth, so area of this face is L into B. So L into B we can consider 8. Now second face, this is breadth, this is height, area of this part is B into H, so B into H will be 18. In this face it is length, this is height, so area will be L into H, and as per the question this is 25, so H into L is 25. So we got 3 equations, L into B 8, B into H 18 and H into L 25. Now if I multiply these 3 equations, then I am going to get L into B into B into H into H into L. It will be 8 into 18 into 25. Here L 2 times, B 2 times, H 2 times. So it will be L into B into H whole square equals to 8 into 25 is 200 into 18. LBH whole square equals to 18 to the 36, so it will be 3600. So LBH equals to root over 3600. Now L into B into H, this is volume, so V equals to, and 3600 is the square of 60, so V equal to 60 centimeter cube. Therefore volume of the required cuboid is 60 centimeter cube, and that's the answer. Question number 5, the breadth of a room is twice its height and 1/2 of its length, and the volume of the room is 512 cubic decimeter. Find its dimensions. Suppose this is the cuboid where height is A. Now as given in the question, the breadth of a room is twice its height. Since height is A, so breadth will be twice A. Clear? We can write here, let height be A and breadth is twice A, and 1/2 of its length. So length divided by 2 is given breadth. So length will be twice its breadth, breadth is twice A, so length will be 2 into twice A, that is 4A. Now volume of the room given in the question 512 dm cube. Volume is length into breadth into height is 512. Length is 4A, breadth is twice A, height is A equals to 512. 4 to the 8 A cube is 512. So A cube is 512 by 8. If I cancel it will be 64. Therefore A cube is 4 cube, because 64 is 4 cube. Therefore A will be cube root of 4 cube, which will give A equals to 4. Therefore length is 4 into 4, 16 decimeter. Breadth is 2 into 4, it is 8 decimeter, and height is 4 decimeter. So these are the dimensions of the cuboid. In question number 6 it is given 2 cubes each of volume 512 centimeter cube are joined end to end. Find the surface area of the resulting cuboid. Now as given in the question, 2 cubes each of volume 512 centimeter cube are joined end to end. Suppose each edge of the cube is A, then this part is A, this is also A, breadth will be A, height will be A. And volume of the cube is 512, so volume of this cube will be A into A into A, that is A cube. So A cube is 512. A cube is 8 cube, because 8 cube is 512, which will give A equals to 8. Therefore each edge of the cube is 8 centimeter. Now in case of resulting cuboid, length will be A plus A, so it will be 8 plus 8, which will give 16. So length will be 16, breadth will be 8, height also will be 8. So we can write here length equals to A plus A, 2 into 8, that is 16, breadth is 8, height is 8. Now we have to find surface area of the resulting cuboid. That means we have to find the total surface area, and formula is twice LB plus BH plus HL. Twice L is, that is length is 16, breadth is 8, 8 into 8, 8 into 16, twice, 16 into 8, 128, 8 8 just 64, 8 into 16, 128. If I add these 3, I am going to get 320, and on multiplying with 2, it will be 640 centimeter square. Therefore, surface area of the resulting cuboid is 640 centimeter square. And this is the last sum from 13b, and in my next video I am going to do sums of 13c. Till then, bye bye, take care, and wait for the next part.